Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at intermolecular forces. Specifically, we're going to look at types of intermolecular forces. Now, atoms and molecules usually interact with each other using different types of chemical bonds and intermolecular forces. Now, understanding these forces enables us to understand why some substances exist as solids, why others exist as liquids, and why some others exist as gases. It also enables us to understand why some substances have unusual properties. Taking for instance, why water has an abnormally high boiling point. It also enables us to understand why some substances melt easily and why some other substances boil easily. Now, the first type of intermolecular force that we're going to look at is van der Waals forces. Now, van der Waals forces are forces that exist between molecules. It is not a chemical bond, it's not an actual chemical bond, but it's an attraction between particles. And there are two major types of van der Waals forces: London dispersion forces and dipole-dipole forces. Now we're going to start with London dispersion forces. Now, London dispersion forces happens to be the weakest of van der Waals forces. And how exactly does it work? So please join me as I explain how this works out. Now, in an atom, there is usually a symmetrical distribution of electrons. Here is you have atom 1. And what happens here is that the electrons are constantly moving around the nucleus. However, it is actually possible for the electrons to temporarily move to one side. And when that happens, this creates a temporary or an instantaneous dipole, whereby you have a positive charge at one end and then you have negative charge at the other end. Now, when this temporary or instantaneous dipole is created, it can actually bring about instantaneous or temporary dipole in neighboring atoms. Now, when you look at the illustration here, this shows you atom 1 when there is a symmetrical distribution of electrons. And then this shows you when an instantaneous or temporary dipole is created. Now, this is as a result of the asymmetrical distribution of the electrons. And then you can see that atom 1 induces or brings about an instantaneous dipole in a neighboring atom, which in this case is atom 2. And when this happens, these atoms will be attracted to each other. So this is basically what happens in London dispersion forces. Now, the strength of London dispersion forces increases with increase in the size of atoms, with molecular mass, and with increase in the number of electrons. Examples of molecules that exhibit London dispersion forces are iodine molecules, methane molecule, bromine molecule, chlorine molecule, and so on and so forth. Now, London dispersion forces exist in both polar and non-polar molecules, but it's actually more prominent in non-polar molecules. Now, using the halogens as an example, iodine is solid, bromine is a liquid, whereas chlorine is a gas. The different physical states that is exhibited by these molecules, these halogens, is as a result of the strength of London dispersion forces. London dispersion forces is strongest in iodine, followed by bromine, and then chlorine. The second type of van der Waals force that we're going to look at is the dipole-dipole forces. Now, dipole-dipole forces are attractions that exist between permanently polar molecules. Examples of molecules in which you have dipole-dipole attraction or dipole-dipole forces. You have hydrogen chloride as an example. Another example is sulfur 4 oxide and methyl chloride or chloromethane. Now, for the sake of this explanation, I'm going to make use of hydrogen chloride. Now, a hydrogen chloride molecule is a polar covalent molecule. It is polar covalent because there is an unequal sharing of the bonding electrons. And this unequal sharing of the bonding electrons results in one end of the molecule having a partial positive charge, which you can see on hydrogen, and a partial negative charge, which you can see on chlorine. So you can see that in this HCl molecule and in this other HCl molecule that is here. Now, in dipole-dipole attractions, what happens is that the negative end of one dipole is attracted to the positive end of another dipole. And that is exactly what we see here. We can see that the partial negative charge on chlorine in molecule 1, this is molecule 1, this is molecule 2, is attracted to the partially positive end of the second HCl molecule. And that attraction is what you can see indicated by these dotted lines here. Now, this is another illustration of what is here. This is one molecule with a partial positive end as well as a partial negative end, and this is another molecule with a partial positive end and a partial negative end. And you can see that the partial negative end of the first molecule is attracted to the partial positive end of the second molecule, resulting in attractions between them. Now, dipole-dipole attractions is actually stronger than London dispersion forces. Now, van der Waals forces generally are responsible for certain properties in molecules that exhibit them. Van der Waals forces are responsible, or they influence solubility, they influence melting point, they influence boiling point of molecules. So these are some of the properties that van der Waals forces influence. I want to believe that this explanation on van der Waals forces is clear. Thank you very much for viewing, and see you in the next lesson.